My name is Michael. It's an honor to share with you this presentation. So you call it technology and energy. That's pretty nice. Thank you. Very control. So you will see that with my colleague Michael and with the team of Pratt & Whitney in particular, we did a lot. We will continue to do it. We will try to guide you in between our strategy of today, tomorrow, and how to. So let's start. So what is our product strategy? We have discussed a lot this morning about what is the market, what could be the market, in US in particular, but also everywhere in the world. What we have to do is an aircraft which is develop a lot of missions, not only for one country, but a lot of missions, versatility. We need to have an aircraft which is very reliable. So probably we can share a lot of there is competition. Yes, there is competition, but competition of the regional market is complex. You need to be very economically wide, and you need to be very reliable. So that's an aircraft, and it was well designed. And you see that it has evolved over the last 40 years. So well born by very good engineers, and we continue with our colleagues again of RTX company. Continuous improvement is our DNA since a while. So I will not detail, but you don't see it. We have a lot of carbon fiber. We have a lot of new technologies in our aircraft as of today, and we will continue to do it for the next step, which will be the ATR. ATR will be the next decade representation of what I just called. So that means versatility, very good aircraft, and very economic. Fuel burn is, of course, our DNA. By essence, turboprop is very efficient. You see in below, we want to increase the ATR value proposition. So basically, the economics, the price experience, SAF, so sustainable aviation fuel is by nature the next step for us. By the way, we are working on it with our colleagues. Not a lot of modifications will be needed here. The certification of the fuel itself will be the key. Mid-long term, this is clearly the Evo for the big evolution. So it's to prepare the next ATR aircraft family. So basically, to renew the propulsion system, but not only to have the new customer experience. And sorry for that. Here we are. So you see the bridge between the two, and the bridge is very smart bridge that we were awarded last week. And I think we can share with them that we were awarded together, so that it was a great teamwork with our colleagues from RTX, not only Pratt Canada, but also colleagues and all the family, and also with other colleagues in Europe. So what is Clean Aviation? Clean Aviation is a European Commission project which is fulfilling one gap, which is we want to do a more sustainable aircraft and less fuel and CO2 emissions. So that's basically, it's a big project, a big program in Europe. And we were awarded, so two main companies were awarded, so namely Airbus and our ultra-efficient regional aircraft, which is Evition. So we can be proud. It's a very honored way to share with our colleagues this award. The aim is to have in 2029 a flight demonstrator, and it's a very important topic. Why demonstrator? Because we want to show that some new technologies will be on board, and it's working, and we will test it. Then we come back to this. What are we talking about in an ATR? So an ATR is a small machine, but still a big power. So for each engine, so we have, it's a twin engine configuration, we have around 2 megawatts plus of power. So it's a 3,000 horsepower on the shaft of the propeller. So it represents around 2 megawatts per side. So we are using 4 megawatts. It's quite a number of power, which is impressive. And we use this 4 megawatts during 200 nautical miles for the takeoff, the cruise, and the transport 72 max. So if we do 3 years and crunched, so we have several solutions to increase the performances or to decrease the CO2 emissions. So first, of course, obviously, we put batteries, full batteries, so a full electric aircraft, and we try to fly with that. Well, as of today, if we do that, we do the journey for the batteries. We don't transport so much people. And we look at Alex, probably in the near future. I'm not sure you will be happy to transport batteries. Let's see the business case. I'm not sure, but so you see, it's a very complex element. Physical laws are the same for a lot of people. Let's remind that. I think I'm looking at you design a very good aircraft. Sometimes we try to forget this. Physical laws are the same. So we can twist a little bit, we can be better in some areas, but at the end it's coming back. So today the full electric in that class, and I'm not challenging the smaller aircraft. It can work with smaller aircraft, but in that class it's very complex. The second potential solution to upgauge an ATR 72 is to have an hybrid technology, and this is what we are tackling today with our colleagues. So hybrid technology is to put batteries in a very smart way, to use these batteries and the electrical motor where we need a certain boost or a certain class of thermal engine. You need to know that thermal engines, what the aircraft manufacturer is asking to the engine manufacturers are in general a very efficient engine most of the time, but sometimes we need to have a boost, which is to say during takeoff at top of climb, we need to have a very powerful engine. So it's a dilemma to have the best consumption every day, but sometimes a very powerful engine. What we do here for the mild hybridization, mild meaning 10% of the power. So we need to optimize the thermal performances of the engine. And when we have the request for this high demand for takeoff or top of climb, we need to use this element for the electrical motor, which will be attached to the propulsion system and to the thermal engine. So this is the concept. And you see that the fuel burn could be better, and that the overall concept could work. Last potential solution is obviously the hydrogen-based. Also could work. The problem as of today, and Miguel will come back to that in the roadmap of RTX, is that today the technology to embark the hydrogen is not really ready, whereas on the engine side it could be ready. So we are also looking at that, but it will be for us as aircraft manufacturer a far future. But it's promising. So what we see as potential solution is clearly the hybrid solution. So that means we keep the thermal engine and we add an electrical motor on the gearbox to use this extra power when we have the. So we optimize for every part of the flight. I will not detail all this, but it's to show you what is the ATR Evo. ATR Evo will be a lot of new technologies. We discussed about mild hybridization, but a lot of other topics will be tackled. I'm talking about avionics, auto throttle, single level, and a lot of propulsion system areas. Obviously, we need to, if we need to be CO2 emissions reduction, we need to work a lot with our engine manufacturer on that. Noise reduction is obviously also part of the performances. So propeller configuration 6 or 8 blades. And we want to work also on the nacelle, the fuselage, and all the structural. The cabin is obviously part of the effort that we have to do. My great time to explain to you all the new cabin concept we want to put. It will be the concentration of all of this. And the last topic will be the aerodynamic optimization. So here it's to optimize the performance of this aircraft, which is already very good, and you see that the shape could evolve with a smart way to reduce also the CO2 emission and the overall efficiency. Targeted entry into service is 2035 euro. And I will let Michael explain the roadmap of RTX on all that we started.
Thank you, Daniel. So at RTX, Collins Aerospace, Pratt & Whitney, Raytheon, we come together and we're looking at all domains of flight, and we're focused on the technologies that enable the future for all of our markets. And so in propulsion, we're particularly focused across Pratt & Whitney. This year is Pratt & Whitney's 100th anniversary. We're really excited about that. And as we celebrate the last 100 years, we're looking to the future. And so I wanted to talk to you a little bit about what are the technologies that enable and unlock that future. And the first and foremost is that we see potential for improvements in efficiency. Both the thermal efficiency, that's what happens in the core of the engine, where you take the stored chemical energy and you release it as heat, turning it into motion on a shaft, and propulsive efficiency. And that's true whether it's a turboprop or a turbofan. And we see runway, we see opportunities to improve both of those efficiencies. And the program that Daniel just described, I'll show you precisely how we're doing that in this particular program. Now, as Daniel pointed out, all electric is not an option today. Batteries are just too heavy, and mass matters a whole lot when it comes to flying machines. Batteries are about 40 times heavier on an equivalent energy storage basis, and that's at the cell level. It's not to put it in a box. The box has to be fireproof, any current management, any thermal management. By the time I do all that, I've doubled whatever mass that was. And so the question is, where's the value proposition? And it turns out it's in hybrid electric. Now, hybrid electric, it has nothing to do with arbitrage. It's not like we're plugging in and charging it, and then we're using electrons instead of fuel. What it is we've reimagined the propulsion system. And we envision the propulsion system as a cyber-physical machine with computer theta control that allows us to optimize where that energy is drawn from for each and every part of the mission, for each and every segment, and for each and every transient in particular. And so by taking advantage of that, we found that we can apply this with motors, drives, generators, distribution systems that we've developed at Collins Aerospace, and then we integrate those thoroughly into the propulsion system. And we're doing this across all domains, from urban air mobility. We have a scalable turbo electric propulsion building blocks where we've actually run the entire mission in a copper bird on the ground. We've got a number of applications, including the Pioneer Lab joint partnership with Airbus for a helicopter, which uses, again, those mild hybrid electric, in that case 250 kilowatt motors, drives, generator, distribution system, etc. The turboprop program, both one that we've been running as well as the one we're announcing and sharing with you here today, that's focused on the ATR in particular to inform the next generation of commercial products. And we're also doing this in the turbofan space, modifying essentially the engine from an A320neo 1100G with our partners MTU, GKN, and Airbus. It's part of the Clean Aviation Switch program for, again, a mild hybrid electric instantiation. So again, same building blocks, same individual components, but we system engineer them and architect them into something that's optimized for each and every one of the discrete missions. Hydrogen. We love hydrogen. It turns out, apparently, we ran engines on hydrogen in 1958. It was for a program that was supposed to replace the U-2 to fly at 100,000 feet. We borrowed those technologies, and we actually conceived and started to build demonstrators around some of the technologies associated with this for large engines, which take all the challenges of hydrogen. It has 3 times the energy, but takes up 4 times the volume. So you have to store it as a cryogenic liquid at minus 253 degrees centigrade. That's a challenge for a big airplane. It's even more challenging in a smaller airplane. When you burn hydrogen, you make more oxides of nitrogen. When you burn hydrogen, you make more water. Water vapor participates in changing the up and down of the Earth, and it also contributes to contrails. And so we took that, we combined all those into an opportunity, we call it hydrogen steam injected intercooler turbine engine, or AirInsight, and we demonstrated the base components on the ground. We're also working in Canada on a program called AMES, funded by the Canadian government, which we take the same engine, the PW127XT concept. We have taken the combustor, and under phase 1, we're doing the modifications to the combustor to be able to essentially burn hydrogen as part of the option. And there are later phases that take that towards a full engine. And then it's important to note that as we do all of this, we never want to compromise on the other parameters that matter to the flying public, things like noise, things like emissions. And so we also are extremely conscious of improving the technologies further. Why don't you go to the next slide? So, as was shared, we did announce a partnership with ATR and Pratt & Whitney Canada to focus on the studies for the EVO concept. This was announced in the Beijing in June, and we're really excited that we've been selected in partnership with ATR to build and fly by 2029 a demonstrator that has essentially replaces one of the engines with a hybrid electric. There are other technologies in there. There's a new propeller that takes advantage of greater aerodynamic efficiency and lower noise. It's got the mild hybrid electric with comparable same motors, drive generator, distribution equipment integrated into it. It's got a new computer, and then it's also integrated into an air gearbox to take advantage of all that. And so maybe what I'll do is just let Daniel sort of describe the rest of the things on the airplane a little further, and then we'll dig into some of the technologies.
Yeah, to complement what Miguel is saying, the propulsion system at aircraft level, we have a lot also to do. We are dealing with high voltage. High voltage is a nightmare to manage, so we will have to test it on board. The chance we have is that we will have a demonstrator to show all these new technologies. So it's easy to discuss on paper studies, to discuss on a lot of things, but we will see and we will be the ones doing a demonstrator. So we are lucky to do this. It was not by chance we were awarded because I think we were quite all about companies with an S at the end, but it's nice to see that. So we will include also the batteries technologies, and as you see here, we will have on the left wing the normal engine as of today, so the Pratt 27XT, and we'll modify the right wing with all the flight test instrumentation on board. So that will be a great challenge. Of course, we will keep you aware of that technologies and test bed, because it will be a very nice test bed for all the companies of FTX, but also all our partners. I'll let you, Miguel, on this, showing the complementary of the aircraft level and the systems and equipment level.
So we start by looking at the thermal efficiency of the engine, and we're going to be introducing new improvements to the aerodynamics within the turbo machinery of the engine. And those enhancements, just as I said, we'll continue to bring those forward, and we'll have the opportunity to insert some of those technologies and demonstrate some of those technologies as part of this. We also will bring a new propeller system developed by Collins Aerospace. That is an integral part. And then we take the electrical components for the hydroelectric. They're coupled into a new gearbox that takes advantage of both the feed from the gas generator engine as well as the electrical system. And finally, there's a new computer system, but the computer system not only manages sort of the draw of the power and integrates that to optimize for the mission, but it also introduces pitch and throttle control in an integral fashion. So you can thoroughly sort of close the loop on the controls of the airplane. And not only is that reduced pilot load, but it also gives you greater avenues for some of the efficiencies. The model is shown here. There's actually a model out there next to the coffee bar that we saw during the break. And this illustrates all of the key components, the new components, and the improved components that go into this engine. We're really excited about building this up, running the enhancements on the ground, building the flight demonstrator capability, and taking it to flight before the end of 2029. So that.
Yeah, so you see that we do a lot at both equipment level, thermal machine, elements, propellers, and we do also a lot at the aircraft level. So this is really complementary, and at the end what we want is not to have an aircraft for engineers. No, we don't like aircraft for engineers. We want to have aircraft which are good for customers to make money and to be reliable and very economically valuable. This is the aim. And we don't please all engineers, but we ask for a lot of engineers, so that's the bit different. I like the elegancy of having a good aircraft, good not in terms of technology. This is quite important.
So I just want to illustrate, we're doing this to learn out the building blocks, to get to technology readiness level 6 on each of the components, but more importantly, to integrate those into an integrated system that can be demonstrated. The program has asked us to not only show the technology maturity of the bricks, the building blocks, but also to achieve a certification readiness level of 6 so that the technologies can be seamlessly integrated into a new aircraft and impact the market, impact fuel burn at the end of the program. The aims of the program are to have ultimately at the propulsion level 20% and at the integrated aircraft 30% improvements in efficiency. It's also important to note that with these new technologies, we're introducing this high voltage directly into the engine. And so we're learning a lot and we're working through with the certification authorities because normally the electrical system and the propulsion system have different chapters for certification. And we're integrating those and we're learning how to integrate those so that when there's a product going forward with and to develop, we'll have all that learned out and ready to go for seamless introduction after a potential launch of a program.
Yeah, just to finish on that, because I think it's very evident in this presentation what we want to do and what is the aim. The demonstrator is not aimed to do technologies and to test technologies. It is, but not only. The final aim is, you have it on the right, it's to feed the EVO program very clearly. It was from both companies, but also at the European Commission to say, gentlemen, don't do technologies just for technologies. We are not interested to do that. We want this program. Is it feeding the program? If yes, be my guest. Otherwise, no. So you see that there is one-to-one from the demonstrator that we want to fly up to the EVO program. So a lot of new technologies on this ATR, a lot of new technologies, even if we have a lot as of today. As I said, the avionics is up to date. We have the same type of modular avionics than the A380. We use a lot of the Airbus control. We use a lot of carbon fiber, the same that the 350 is built with. So this is a new machine, but will be a new evolution based, of course, on the demonstrator of the generation. So you see that we will work a lot on the propulsion system, the avionics, a lot of the propellers with our colleagues. Final aim to do a good aircraft. We all know that a lot of engineers are working on it. So to have all these challenges and at the end to have a good product which is reliable, where I'm really fascinated by our customers. Chris, if you want to follow me, we have a lot of customers, all very different. But at the end, what I like is when they are coming to me saying, your aircraft is really a good aircraft, because when I turn on, it's turning on. Just a simple matter, but to do it at a 99.5 or 6% for every mission, we do around 10,000 flights per day with ATR, so it's huge. So look at this. So to have technologies proven, tested with our colleagues of RTX and others for the here we are. Thank you, Mikhail.
And building on the reliability of the ATR, building on the reliability of the PW100 family of engines, with over 200 million flight hours over the last 40 years, we're taking it to the next generation. We're making it hybrid electric. We're improving the engine. We're integrating that with the computer controls, and all that's going to be the opportunity to move forward into this.